You think about milk, right? For a newborn baby, it's everything. It's the perfect food, the source of life and growth. But what if, for some babies, that very thing, that perfect nourishment, was actually a poison? That's the medical mystery we're going to unravel today.
So that's the big question, isn't it? How can something so fundamental, so vital, become dangerous? To find the answer, we have to go microscopic, deep into our own biochemistry. So first things first, let's take a look at how the system is supposed to run.
All right, so before we can figure out what's going wrong, we need a blueprint for what's supposed to go right. We're going to follow a specific sugar from milk, it's called galactose, and see what its normal journey through the body looks like. This whole journey takes place on something called the Laloyer pathway. Now, the easiest way to think about this is to picture a super efficient, 4-step factory assembly line running inside your cells. It's got one job and one job only. Take that galactose from milk and convert it into pure energy. Okay, so check out this assembly line. Every station has a specialized worker, which is really just an enzyme. First, you've got GALM, who gets the galactose all prepped. Then, worker number 2, GALK, comes along and slaps a phosphate tag on it. Next up is GALT, and this worker does a really important swap. And finally, GALE finishes the job. When all 4 of these guys are working in perfect harmony, boom, milk sugar becomes fuel for the body. Simple as that. So, that's the perfect system, the blueprint for how it should work. But in our medical mystery, this beautifully tuned assembly line, well, it just breaks. It grinds to a catastrophic halt. And now, we're going to find out why. And here's the thing. It's not like the whole factory shuts down. No, it's way more specific than that. It's like one single, absolutely essential worker just didn't clock in for their shift. And that is our culprit. The condition is called classic galactosemia. And the entire problem, the whole thing, boils down to that one missing worker on the assembly line, the GALT enzyme. Without GALT, the entire process is dead in the water, right at that one critical step. I mean, just look at the difference here. It is night and day. On the one side, you have that healthy pathway. Galactose goes in, energy comes out. A nice, smooth flow. But on the other side, without that GALT worker, the galactose comes in, starts down the line, and then, wham, a complete and total roadblock. Everything just piles up. So what happens when that assembly line gets jammed? Well, all that material that's supposed to be processed, this stuff called galactose 1-phosphate, it just starts building up. And this buildup, it's toxic. And that's where the devastating fallout begins. For a newborn baby, the consequences are just immediate and severe. Shortly after they drink milk, they get incredibly sick, vomiting, diarrhea. They stop gaining weight. That toxic buildup starts to wreck their liver, damage their brain, and can even lead to overwhelming infections. And let's be crystal clear, this is not just being lactose intolerant. This is a full-blown, multi-system medical emergency. Let's zoom in on one specific symptom for a second, because the science here is pretty wild. Since that main pathway is blocked, the body desperately tries to find other ways to get rid of all this extra galactose. One of those backup routes converts it into a substance called galactitol. Now, this galactitol starts to collect in the lens of the eye, and it acts kind of like a tiny sponge, just pulling in water. The lens swells up, it gets cloudy, and that's what forms cataracts, which can lead to blindness. Now, you might be wondering, how common is this? Well, it's considered a rare disorder, affecting about 1 in every 40,000 newborns in Western countries. To put that in perspective, a decent-sized city might expect to see maybe 1 new case a year. And because the symptoms are so severe and happen so fast, most places now screen every single newborn for it right after birth. And that simple test, it is literally a lifesaver. Okay, so we know that the missing GALT enzyme is the big problem. But to really nail down why it's so catastrophic, we're going to do a little more detective work. We're going to look at what happens when other workers on the assembly line are the ones who go missing. This is where it gets really interesting. All right, this table really lays it all out for us. We've been focused on type 1, the classic galactosemia, where GALT is missing. But now, look over at type 2. In this one, it's the second worker, GALK, that's gone. And what happens? The main symptom is just cataracts, and the long-term outlook is generally good. And that right there is the smoking gun. It tells us that galactose piling up by itself isn't the real villain causing the severe liver and brain damage. It proves that the real poison is that stuff that gets stuck in the middle of the assembly line, that galactose 1-phosphate. So, we've identified the broken part of the machine, And we've identified the primary toxin. You'd think the solution would be pretty straightforward, right? Well, it is, and it isn't. Because even with the fix, this condition brings lifelong challenges and one big lingering question.
So what's the solution? Well, in principle, it's incredibly simple. If the factory is broken, you just stop sending it the raw materials. And that means a strict, lifelong diet that is completely free of lactose and galactose.
And in the real world, this has to happen instantly. The second a baby is diagnosed, breast milk is out. They're switched over to a soy-based or some other specialized formula. And from that day forward, for the rest of their lives, they have to avoid all dairy products and even hunt for hidden sources of galactose in other foods.
And don't get me wrong, this diet is a game changer. It works wonders on those immediate, life-threatening symptoms. The severe liver disease is largely prevented. The cataracts can often be reversed, but, and this is a huge but, it is not a perfect cure. Many patients, even when they follow this diet perfectly their entire lives, still experience long-term complications.
And that brings us to our final, profound question. If patients aren't eating any galactose, why do so many of them still struggle with long-term issues like speech defects and cognitive impairment? Well, the theory is that maybe our own bodies produce a tiny amount of galactose internally. Or maybe that the initial damage done in just those first few days of life has lasting effects that can't be fully undone. And that is the edge of our current understanding. It's the part of this mystery that scientists are still working tirelessly to solve.